have the full screen, and my second lecture today concerns the ground-based observations, basics, approaches, and applicability. And I will begin with these famous slides for my PCC. We just showed you the history of different measurements in the world since the end of the 19th century up to nowadays. And you see that the beginning of measurements were based on these surface measurements. Of course, it's much easier with the standard meteorological measurements. Then we add some gas measurements, for example, total ozone in the 20th of the 20th century. And then in the second part of the last century, the satellites measurements, the era of satellites measurements began. But today I would focus only on the ground-based measurements, and also I will just mainly will speak about the very interesting and very helpful system is the Global Atmospheric Watch, which is a worldwide system established by the WMO. And the main aim of this organization was to monitor trends in the Earth's atmosphere. And it arose of our concerns about the state of the atmosphere in the 1960s. But why do we care about the state of the atmosphere? Just the London smoke of the December 1952. This is the pictures which were just received directly from this event, which brought about 12,000 victims due to the unprecedented, very unhealthy quality of the air. And since that time, and just at the beginning of the 60s, a lot of the program were adopted in Europe and in the US. One of the major aspects of this GO mission is to organize, participate, and coordinate assessments of the chemical composition of the atmosphere on a global scale. And this, of course, partly concerns the emissions and primary air pollution, transport oxidation, chemistry, cloud chemistry with taken into account for the washout processes, secondary air pollution, deposition, air quality, and health. So all the things that we have already discussed today and during the lectures you already heard. Just you may find in the internet these reference to the global atmospheric watch station information system, which is very, very helpful. And you see the map with the colored with different colors, which just denote the ground-based measurements all over the world. What is the structure and focal areas of the GO? It, of course, the infrastructure concerns the directly GO stations, their central facilities, and the quality assurance procedure, which is quite necessary for the best quality of measurements. All these data combined in the world data centers and contributing networks. The focal areas of the GO is combine aerosol, greenhouse gases, reactive gases, stratospheric ozone, ultraviolet radiation, atmospheric deposition, just gourmet modeling application, gas sump, and so on. And these information can be used for different services. Here is the framework of the GO quality system. This is a very, very important point that we should check all our measurements. We should test them against the standardized instrumentation. And so we have so-called primary standard instrumentation, secondary station, which is going to the world original calibration center. And then after the standardized quality assurance procedure at this center, other instrumentation are calibrated in similar ways. That's why we can compare the measurements which are taken at different stations all over the world. And so you see here is the GO station itself and World Data Center, which is which collect all these measurements. So these slides demonstrate the Go Global station all over the world, which provide different kind of information. Here, what are these centers? It's the different sensors are responsible for archiving one or more Go measurement parameters. Just for example, begin with the last one is the WRDC. This is the World Radiation Data Center, one of the the oldest one, which we have. Then the World Ozone and UV Data Center. All these just you see this, which contains the data both for the UV radiation and total ozone. Then we have several data centers which collect the data for the gases. This is the center for the greenhouse gases and for reactive gases, and data center for the aerosol. In addition, we have the World Data Center for remote sensing, but today we will not discuss these points since we are focused on the ground-based measurements. Here is the list of the contributing data centers over the world, and you see a lot of the program and a lot of the data centers which we have in addition. Where is the location of these data centers? Just the World Data Center on Solar Radiation is located in St. Petersburg in the main geophysical observatory. So the ozone and UV radiation data center is located in Canada. The greenhouse gases and the aerosol reactive is located in Japan. In Norway, there is the Center for the Aerosol and Reactive Gases, and just some others you see in on the map as well. We will speak today about these data centers, about the data and their applicability. Of course, it's impossible to just describe all of them, but I would like to focus on the main interesting data centers or contributing data centers, which information is possible to use, which are freely available or which is available by the request. And we will begin with the, so this scheme contains three main parts: the radiation, aerosol, and gas monitoring system. And first, we'll discuss the radiation ground-based monitoring, which is based mainly on the WRDC and WOUDC centers, as well as the contributing centers of the baseline surface radiated network, is BSRN. ARM, Skynet, several national programs. I will just focus on it just in my talk. And then we will just continue the description of our other data centers, aerosol and gas data centers. WRDC is the World Radiation Data Center located in St. Petersburg, and it has been established in 1964, and it is collected. It's more than 500 stations all over the world sent the information directly to these data center, and from the 56 countries. and there are a lot of the stations which can be found in the catalog of these data. This is the main parameters which can be found there: the global diffuse direct solar radiation, downward atmospheric radiation, net total and terrestrial surface radiation, spectral radiation components, and the the time step is from hourly to monthly basis. Yes, this is the example of how you can see what you can see the internet for concerning this data center, and the example of the data obtained from the Russian Irkutsk station just for the January, February, and March months of the 2000, just as an example. What instrumentation is used for measuring atmospheric radiation? It's necessary to say because the instrumentation is of different quality and of different parameters. And it's necessary if you would like to have the homogeneous studies, you need to analyze this data very carefully. So the first, I would like to mention the Keep Zoning company. Here is, for example, the CNA4 net balance, which have four sensors for shortwave and longwave irradiance, upward and downward. Here is just for example, a Russian instrument for measuring direct radiation. So you can find here some other instrumentation from the Epley lab. This is the American, as well as Young Environmental System, yes, company. Also, it's like core instrumentation is famous for the measuring in visible radiation, which is necessary for the plants. Also, just spherical instruments is focuses on the UV instrumentation, and there are some other companies which can be mentioned there. Just another contributing very nice data center is the Water Radiation Monitoring Center, which contains the data from the baseline surface radiation network. This is the network which contains not of many stations. There are not many of them, but they are of excellent quality. It's very important to understand, and the data contains from the time step of 1 minute. And here is the map of the BSRN network located all over the world, just very spread in different continents, in different geographical conditions. Another contributing radiation data center is the atmospheric radiation measurement program. This is the American program, but they have the measurements using the station or moving facilities all over the world. You see here is also the map, and the data are very interesting because they are consist not only of the measurement but also the some modeling results, and there you can combine them, and there are a lot of the very good tools for the analysis. Another data set which is open for application in your study is the data from the Global Monitoring Laboratory. Earth System Research is a part of the Earth System Research Laboratories from NOAA. And also you may find here a lot of measurements, monitoring programs concerning the greenhouse gases measurement, carbon cycle cycles, aerosols, and of course surface radiation. Here is the map of the National Radiation Network of Russian Federation. You also, by request, can ask the information the main geophysical observatory, which is responsible for this data set. Meteorological Observatory of Moscow State University is famous for its very nice program, especially in radiative studies. And here we can find some, you can just see the instrumentation that we use for measurements of the components of the radiative balance net radiation. And we have also some new instrumentation like keep zone and net radiation CNR4 or new radiative BSRN complex, which we bought just this year, and it has been established, and we have some few first results obtained just in September and October months. Another data center which contains the data on ultraviolet radiation as part of the solar spectrum is the WOUDC, which is located in Canada, and you can find via their site a lot of the information concerning both broadband spectral data set using different kind of model of the instrumentation, and you can see what agency is responsible for different kind of measurements and what region is described by these measurements. Here is one of the map of these data concerning the spectral sites. It's only spectral site, not broadband sites, which is most hard for the calibration and just maintaining. There are some other ultraviolet data sites through the NSF Polar UV Monitoring Network, USD UVB Monitoring and Research Program in the US, European UV spectral measurement, which is maintained by the FMI. And just a few words about them. Here, as you see, the European network for UV radiation measurements, which cover the spectral measurements through the whole European territory. You see much more information if you are interested in Europe territory. Just I would advise you to use this data set. And through the whole world, there is a very nice polar program, which was which was organized by the NSF and founded by the NSF, and they have so you see several points both in the polar region of Arctica and Antarctica, and at their location in San Diego, just for comparison reason. And you see the period of their measurement covered all the period which was just in time with the ozone loss problems since the end of the 80s. So the first measurements in Antarctica began in 1988. And this is the spectral radiometers which were installed and are still working there in different points of Antarctica. There are several stations there, and a lot of interesting results were obtained using this data. So just for example, the UV index at South Pole, which had been then before ozone hole and after. You see, this is the after we have a very interesting shift to the maximum of the UV index, even at South Pole, to the very large values, despite of the smaller solar angle. And this shift is due to the very small ozone content in springtime in Antarctica. Also, I would like to mention the large program of ultraviolet measurements at the Moscow State University. We have the longest in the world period of measurements of the long wave UV radiation through the 380 nanometers since 1968. And since 1999, we began the program of the measurements in UVB regions for the evaluating of the erythemal UVB radiation. And we tried to make regular calibration system against world standard. Here is just the example of these calibration. A few words about the applicability of these measurements. Of course, the ground-based measurements are the most accurate data compared with the satellite data. So they are used for the analysis, especially long-term monitoring data, and as well for testing satellites retrieval, radiation gas aerosol, surface characteristic, UV radiation, different points you may find in literature. In addition, the applicability of ground-based data is the use of them as input parameters and assimilation them in modeling and testing different kind, not on the satellite data, of course, but the different kind of models. Just few examples. Here is, I just use the examples from mainly from our measurements at the Meteorological Observatory, but of course you may find them just in literature in many other locations. So here's the very interesting trends, positive trends in net radiation in Moscow, which we have since the end of the 50s due to this radiation program, which began since the beginning of the Meteorological Observatory life. Another just applicability of the, for example, UV long-term UV measurements is the use of this data for testing the reconstructed models. And here is the example of the reconstruction model. For example, the by lines it's shown the measurements of the erythemal irradiance, and by dots shown the reconstruction of the erythemal irradiance through the very long period. You see the very clear positive trends during the last years. Also, the data from the shortwave radiance have been used for the testing of the updated model of reconstruction of the solar shortwave radiance. And this is the data of our recent study, which you see quite good agreement with the measurements, so we can trust that our model of reconstruction, even for shortwave radiance, works very nice. Also, I just already showed you these slides in the morning, but I'd like to show it again because it's the testing of the 3D Monte Carlo model using long-term cloud amount transmitters of different cloud amount values. And you see by lines it showed the calculation with the 3D model, and by red line is the measurements at the Moscow State University. And just for the line, the bold line, it shows the measurement of degrees. So this work was very old, but it's a very good example of how the data can be used for testing different models, for example. And testing of satellite retrievals can be seen from the testing of the ground-based UV radiation of two algorithms available from TOMS and Meteosat. And you see here it's a very interesting result that the standard Meteosat and standard TOMS data provide a very large difference against measurements all over these long-term periods since the era of the satellite data. But after aerosol correction, which we propose to do, correction by the absorbing aerosol, the agreement is getting much, much better. This was just examples of the applicability of the radiation data, and we go on and just discuss some results on aerosol. Here is we have the global atmospheric wash data center for the aerosol and some contributing data centers, SMASH and AeroNet, Photon, Erican, Skynet, and some others. Here is how you can find the aerosol data center here, and some parameters which are in this center. They are both ground-based information as well just chemical properties, microphysical properties, optical properties, as well as the vertical characteristics as well. The one of the contributing center for the aerosol is the Actris data center. It's also the open portal which have the information on aerosol, and you can allow you to search, analyze, and download the atmospheric composition data. Here is just the example of the distribution map of these points and just some information on the parameters which is in the Actris data set. You may analyze trends using this data. Just for example, here is the trend analysis for the aerosol optical thickness obtained from our meteorological observatory data set for this server. And applicability. Of course, this is, as I already mentioned, this is the long-term analysis and trend analysis, which is quite important in our climate change life. I would like, of course, to mention and to just show some results of the AeroNet network, which already mentioned by my previous colleague in his lecture. It's really very good, very friendly data set. It's open to all whom it may concern. And here is the network. It's more than 500 stations, and you can download, display, or download data on aerosol optical thickness or on the so-called inversion program products on it. So this is a very, very interesting and very good data set. Just the applicability of these AeroNet results, which we have at our meteorological observatory since 2001, is the very pronounced negative trends in aerosol, except 2010 when we have the far effects at different wavelengths. And another kind of applicability of data is just the comparison with the model data. Here is, here is the results of the comparison with the, for example, PM10, the particulate matter with a diameter less than 10 micrometers, and just the compared of the model and measured values of our data we just over our point of Moscow State University. Here's another example of just testing the Mayak modus retrieval against AeroNet data set. You see quite good agreement for different aqua and terra measurements. Another kind of applicability can be found in the ARACOM work. It's a very good data set which contains both measurement and model results of aerosol. And this can be found on their page in the internet. And we go on to the gas and describe the global atmospheric watch data center for greenhouse and for the reactive gases. Greenhouse gases, data center for the greenhouse gases is located in Japan. And here is the map which showed you the distribution of the different local points of the measurements all over the world. And some results, for example, here is the results of the CFC. This is the greenhouse carbon ozone depleting gas species of summit. This is Greenland, and you see just the trends in these species of summit. It also can be available through this data set. The World Data Center for Reactive Gases is hosted by the IBES home. This is Norway, and also there is a lot of the data set there. Another network, contributing network to the gases is the network for the detection of atmospheric composition change. You see a lot of stations which are included in this network, both in different geographical regions. And here is the main stations all over the world which provide their measurements to this center, to this NDACC center. For example, here is the example of the station in St. Petersburg, and the instrumentation FTIR interferometer, which is work at the roof of the St. Petersburg State University. Again, we return to the ozone, to the WOUDC Center, which contains, in addition, the data on ozone. And here is the picture which demonstrates you the instrumentation. This is on the left, you see the oldest Dobson spectrophotometer, which is used since the beginning of the 19th centuries and from the 20s. For measuring the total ozone, and there is a very nice papers of these long-term measurements in Switzerland, for example. And using this web page, you can easily bring for the analysis, take for the analysis different data from different sites. Here is, for example, just the list of this site, and with the characteristics. And here is the map where we have the daily observation of total ozone, using different kind of observations. So again, about the applicability of this data, I mean not only the total ozone, but the gas species, different gas species. Here is the example of the compare of also the validation of the chemical transport model, and just on the example of the Cosmo Art model, which is used in Russia. Gives the measurements of the different gas component. Sorry for this title is not right. Here is we showed the CO ozone. This is the surface ozone, of course, NO2 and NO components. For different, in black colors just show the measurements, and in red the model with different conditions. And you can see that unfortunately for this day the model was not very good. We have a lot of difference which we need to understand, but it's very good for using the measurements just for the comparison with the model results. And my last slides concerning the this is from the ozone assessment. The different the changes in ozone depleting substances for different elements. Just here is the, for example, CFC 11. It's the what we have already seen, the Japan data center for the greenhouse gases. But as I've already mentioned, this is also the ozone depleting gases, and you see that we have um, uh, the after the increase, we should have the decrease in the emissions in the our period, and the forecast also just demonstrate the decreases to none. But this is the model results. What we have from measurements? We have from measurements the ozone modeling and measurement, and they are shown in the below by the just the black line. It is shown the, for example, this is the model ensemble mean time series of total ozone and the prognostic total ozone changes after its recovery following the Mondial Protocol, and its amends the regulation of these emissions of the ozone depleting substances. And by dots and lines in brown color shown the measurements. And you see this is quite important that here we see quite good agreement between both measurements and model results. That is very, very from I guess that it's a very good result. So that is, I'm sorry, just I have some few minutes for your questions if you have, or I can just finish at this moment. Thank you very much.